Hello, everyone. Welcome to another edition of CDCon, another virtual edition, I must say. Hopefully, this will be the last virtual edition, and Manish and I can meet you guys all again in person next year. But we're happy to talk to all of you regardless. So what does this talk about? This talk is about Spinnaker at Airbnb. You might remember us from previous talks about the same topic. But we'd like to give an update of sort of where we are in 2021. We'd like to talk about how we do continuous delivery at Airbnb, share some ideas around how we use Spinnaker, how we configure it, how we extend it, and hopefully you guys can take some lessons from this and apply those to your own companies. We would love to continue this conversation offline as well. So who are we? My name is Jens. I am originally from Belgium. I am a software engineer at Airbnb. I work on the continuous delivery team. So really my day-to-day is always involving continuous delivery. I was originally a front-end engineer, and then when I joined Airbnb a couple of years ago, I transitioned into infrastructure. You might also know me from the special interest group around CI on the open source side of Spinnaker. Manish?
Thanks, Jens. So I'm Manish. I'm a product lead here at Airbnb. I focus on developer tools for DevOps and reliability areas. Previously, I was a PM at AWS.
So let's take a little overview of our presentation before we dive deeper. So we'd like to talk about 3 different topics today. The first topic is Spinnaker general availability. We'd like to talk about how we achieved general availability. 2021 was really a breakthrough year for us. Spinnaker is the default deployment tool at Airbnb nowadays. We'd like to talk about how we've achieved that and the lessons that we've learned along the way. We'd also like to spend some time to talk about UI and UX improvements that we've made to Spinnaker. How did we solve those issues? What were those issues? And hopefully we can share some of that, and then that can come back into the open source community, and we can potentially upstream some of those changes. Last but not least, we'd like to talk about how we've extended Spinnaker with new features. We've really chosen Spinnaker because it's a flexible tool for continuous delivery. I'm sure a lot of other companies are looking at Spinnaker for those exact same reasons. So we'd like to talk about how we've extended Spinnaker on our side to fit some of Airbnb's specific use cases. Manish is going to talk about Spinnaker's journey.
Great, thanks, Jens. So I'll go over the Spinnaker journey with you all, and how Spinnaker journey at Airbnb with you all, and how from where we started to where we are today. I'm pretty excited to share this with you all. So next slide. Cool. So Airbnb, like most of the startups, started with a monolith architecture. It really worked well until the engineering organizations started to grow. But then we started to experience challenges with reliability and the development velocity. Changes affecting the downstream had to be coordinated, and many times were missed, causing outages. To innovate and to respond to changes faster, we modernized our tech stack to be modular and cloud native. This led to explosion in the number of microservices running in containers, which led to a significant uptick in the number of deployments that we had. Next. This move to a modernized architecture led to several new challenges, and one of them is outages due to code changes. We were still using our in-house deployment tool, which was built for monolith. This particular tool did not support deploy pipelines and orchestration of complex workflows. It was not even built for like our cloud native workloads. Any outages had a significant impact on our host and guest experience. Imagine you had to you have traveled with your family and are having issues trying to check in into your Airbnb. You open the Airbnb app only to find out that you are unable to connect with your host. You are now stuck and frustrated, and we as a company don't want such experiences. We want our system to have high availability, to provide magical trips to our guests. So that is the impact of outages on the Airbnb product. We also ran a study to identify inefficiencies in the built as deploy loop, and realized that there were several manual steps still needed for the change to go from master to production. This led to an increase in the time to production for new features, but also had a lot of inconsistent release patterns, which led to outages. And this was mainly because even though we moved to a cloud native architecture and more towards like SOA or microservices architecture, we were still using a tool which was designed for a monolith system. In the when I talk about the development workflow with the old tool, basically it worked like a service operator had to remember to start a release. They would cut a release branch, run some verification tests, and in many cases hand over the changes to the QA team. QA team would run these tests and hand it back. Then the developer would deploy to pre-production fleet, manually verify a few metrics, and then promote the release to production. In many cases, depending on how senior you are as an engineer, you may even miss these steps, which led to outages. Finally, once your change is in production, the developer would have to monitor those production for the next few hours to make sure that there are no regressions. So in order to overcome these challenges, we made a decision to invest into an automated release process, and started investigating options that we had to reduce the outages, and then also improving the developer productivity. Next. So as I mentioned, our tool did not have the concept of pipeline, and it was not built for cloud native stack, which led to a lot of inconsistent release patterns leading to outages. We made a decision to transition to Spinnaker, which was purpose built for cloud native workloads. We did evaluate a lot of various options and landed on Spinnaker, mainly because it served our purposes. It served our needs, and it was an open source tool, and we also had to customize a lot of Spinnaker, a lot of Airbnb specific patterns into a tool, and Spinnaker, being an open source tool, provided those capabilities. With Spinnaker, we got fast, repeatable, and safe pipelines, which significantly improved the overall reliability of Airbnb product. Next. Spinnaker helped. So Spinnaker helped with standardizing and visualizing the release processes. Automatically running the verification tests and limiting the deployment blast radius using automated canary analysis significantly reduced the outages due to code-related changes. This resulted in a better experience for our host and guests, as the number of outages was reduced significantly. Previously, very few teams deployed to Canary at Airbnb and had inconsistent KPIs to monitor if a particular change that was deployed was stable or not. Using automated canary analysis, or ACA, teams encoded these meaningful KPIs, and then the ACA judge provided a result by checking those KPIs for that particular canary. And all of this was done automatically, which was great for the teams because they were more focused on feature launches than just the deployments. Developers were no longer babysitting their deployments. They would check in their code and move on to the next task, increasing their productivity. It was easy for service operators to reproduce an issue in the release as the deployment pipeline was codified, and it was easy to audit each step in the release process. Next. So on the challenges side, we ran a pilot of Spinnaker with a few teams and uncovered significant challenges. In any migration, ensuring a smooth application migration is always a challenge. It was crucial for us that that the migration occurs without any hiccup to the everyday release processes. The teams did not trust the tool early on because it was still very early and not many services were using it. We made a decision to allow teams to continue using the old tool, and teams that use Spinnaker were also allowed to use the old tool, so that if Spinnaker had any issues or any use case was not supported, they always had an alternative. Not having enough resources to start using Spinnaker was one of the top cited reasons from our customers. They had the commitments to launch features for our host and guest, and it was mainly a prioritization issue. Should they be investing more on the reliability improvements versus the features for the business? During pilot, we realized that there was a steep learning curve in terms of using a new tool and also adopting a new culture of continuous delivery within the company. The pilot also uncovered several features that our developers loved in the old tool, and these feature gaps were a significant blocker for a wider rollout within the company. And finally, folks in the Spinnaker community are aware of the quirky UX and troubleshooting challenges that the Spinnaker open source product has. So those were the significant challenges that we had while rolling out Spinnaker within the company. Next. On the timeline wise, in 2019, we completed the POC for Spinnaker and started the pilot. In 2020, we launched Spinnaker for all internal services within the company. We made it default for all new services. In 2021, we are adding support for new workloads such as data and AI/ML workloads. In future, we plan to add feature flags, blue-green deploys, and managed delivery. And managed delivery is basically a declarative approach to orchestrating releases according to the requirements rather than stitching specific release steps together. Next. So what worked for us? How did we get the entire company invest into a completely new deployment tool at a time when we were focused on launching new products for our host and guest, such as online experiences, and like everyone else, dealing with strategic changes due to the pandemic. So mainly we focused on three things. First, we focused on customer benefits. We did not force anyone to migrate from the old tool to the new tool. We provided a new tool as an alternative to the existing tool. We helped customers realize 10x benefits from moving on to Spinnaker by enabling them to increase the productivity of their teams, and also significantly improving the reliability of the services that they own. Second one was the ease of getting started. We provided tooling and also really significantly reduced the friction to onboard onto Spinnaker. I'll go into a little bit detail on the next slide about this. Third, we also empowered the team to look at success metrics and report on the business impact. Basically, think about metrics such as how did Spinnaker increase the service availability or the service uptime for that particular team, and then also prove that Spinnaker can prevent incidents and regressions. I highly recommend using this strategy for any products you launch, especially the internal the products that you launch internally. Next. So this basically goes over the ease of getting started piece, which is the automated onboard. All our services, all the teams with a default pipeline config, which had the stages for launching to pre-production and production environment, and also had a default stages for integration test and ACA. So as a customer, you would just use a single command, provide a service name, and you'll automatically get these default configs for your pipeline, and you are up and running within few minutes. Next. So where we are today, from where we started as a POC in 2019 Q4. Today we have around 700, actually more than 700 monthly active services, and monthly active meaning these services are deploying, have active pipelines, are deploying to production on some frequency. Our more than 75% of rollbacks have been prevented by Spinnaker. Think about this metric as out of 100 deployments, we were able to catch 75 deployments that would have resulted in some kind of incident. And then finally, more than 65% of all our critical services are now on Spinnaker and valid are being is using ACA for the verification of the change, make sure that the change is stable. We have also increased the deployment frequency from weeks to several times a day, and this has significantly improved the developer productivity and also reduced the time to market for new features within the company. Next. So finally, I just want to share this graph with you, which is the uptick, the exponential growth that we saw in 2020 as soon as we launched and we used the 3 tactics that I mentioned, and we have more than 700 services today that are using Spinnaker, and we are adding more workloads within the company. So finally, using the 3-prong approach, basically first one, benefits, second is really making easy to get started, and then third, empowering the team to look at the success metrics, really helped us achieve this growth in the Spinnaker adoption within Airbnb, and I highly recommend using a similar approach within the products that you launch.
All right. Now we'll dive a little deeper into some of the things that Manish talked about. Let's start with the UI and UX improvements that we've made to Spinnaker. As Manish mentioned before, when we started adopting Spinnaker, our customers had some friction with Spinnaker's open source UI and user experience. We did some customer research, and here are some of the quotes that some of the engineers at Airbnb gave us. The UI is confusing. It's hard to identify live builds. It's unclear how CI and CD are integrated. This makes remediating incidents error-prone and difficult. This was a very common feature request or very common piece of feedback when we initially started rolling out Spinnaker. The other section of comments that we've got revolves around the debugging experience. Engineers mentioned to us that it was often very difficult to debug a pipeline failure. It's a difficult experience that has often cryptic error messages, especially when it comes to the failures related to automated canary analysis. Now, this is actually pretty important to us because when engineers are debugging a pipeline failure, they may or may not be in an active incident, and we want to make sure that we can resolve incidents as quickly as possible without the tool getting into the way of the engineers and the day-to-day workflow. So what did we do? The first thing we did is we've integrated Airbnb's CI platform. We really wanted to make sure that Spinnaker is not a standalone tool, but it integrates within the entire CI/CD story and doesn't just do CD. So what we did is we basically created a new page in the Spinnaker UI called snapshots, which will pull in information from our internal CI service and display a list of snapshots, also known as builds or commits within you for anyone else who is using Git as source control. So what these snapshots allow us to do is they basically allow us to correlate a deployment with a source control commit. This is very powerful because in one view, we can actually tell which CI run was eventually deployed into production and how does CI and CD integrate with each other. We've also made some maybe minor, but still important changes to the pipeline executions view. As you can see here, we've made it more clear which pipelines deployed to production. We've made some small changes to make it more easy to spot how CI and CD are integrated. And we've also added some more prominent colors around failed pipelines so that developers can quickly see where a pipeline failed and why a pipeline failed. The last thing we did is we actually added an improved deployment history view. So now that we have this metadata around snapshots, we can actually correlate deployments with a certain CI build, a CI run. And we do have the pipeline executions view, which will actually show us which snapshots went through specific pipelines. But our developers actually wanted more information. They wanted a different perspective on the same data. So what they really requested is, show me the last 15 production builds. Now, in our use case, we might have multiple pipelines that can all deploy to production. So finding that information in the pipelines view can actually be pretty difficult. So what we did is we basically created a second view on the same data, but we sliced the data by environments and by snapshot. So in this page, you can actually filter on the specific environments. So here we can do something like showing the last 10 production deploys and then actually seeing the pipelines associated with that. So we're using the same data, but we're showing it through a different lens. This deployments view is very useful for engineers who are trying to debug or remediate inactive incidents. And last but not least, we've made some improvements to the debugging experience. We've added small but meaningful touches, like, for example, showing specifically which stages failed, which is very useful. In case of Airbnb, we have some services with pipelines that can consist out of 50 or 60 stages. So getting to the specific stage that failed very quickly can save a lot of time and can potentially save a lot of time during an active incident. Let's also talk about how we've extended Spinnaker with new features, new functionality. How did we do that? Well, actually, Spinnaker is very flexible. Specifically, Spinnaker's Orca service, or its orchestration service. What we basically did is we taught Spinnaker's Orca service to speak Airbnb service IDL, or interface definition language. So what's IDL? It is basically a abstraction layer on top of HTTP that is strongly typed, and that allows Airbnb services to communicate with each other. And so what we did is we added a new stage to Orca that allows people to send specific requests in the Airbnb IDL format. And by doing that, we actually enable people to interact through Spinnaker through a single stage with all of the other services that we have available within our internal tooling. So this allows us to do things like communicating with the CI platform, communicating with deploy boards, our old deployment tool, and even do things like triggering fault injection tests, integration tests. You name it, it is possible with Spinnaker now. We've also added a new feature specifically after some user feedback. So the feedback that we've got was that in CI, when something fails, the CI will fail and they won't be able, and developers are not able to deploy it. But when someone actually deploys a build to a certain environment and a failure gets caught in CD, nothing prevents users from actually redeploying the same change. It's not obvious that a change was previously deployed and had an issue with it. So what we did is we added a little bit of metadata that allows us to mark a specific build as bad. So now when people are actually running a change through a CD pipeline in Spinnaker, and something gets caught in canary analysis, it's very easy to mark that specific build as bad. When the next engineer comes in, they will be presented with a warning not to deploy this build because it actually has already failed CDE in the past. This also makes it easier to find those specific changes that are bad, so engineers can actually go in and revert those changes in source control. We also wanted to make Spinnaker's value very clear to our customers. As Manish mentioned before, we didn't want to forcefully adopt Spinnaker. So what we did is we generated dashboards for each service specifically. So when we've adopted our first few services, we basically had the data to prove that Spinnaker actually improved the reliability of those services. This gave the engineers that initially adopted Spinnaker the tools to go back to their management and say, hey, look at this data. We've actually improved the reliability by using Spinnaker. Now, using this data-driven process, we were able to clearly communicate Spinnaker's value add, and this really helped us getting buy-in from the upper levels of management to push the final stages of our migration plan. We also created an in-house tool for declarative pipelines, Anchor. It's basically pipelines as code. You can think of it as you write a YAML file, and then that spits out Spinnaker-specific configuration. Anchor is Airbnb unique. It's basically an abstraction layer that allows us to generate all of these Airbnb-specific stages, like integration tests that we use the service IDL for that I've talked about before. So with all of that said, it's very exciting that Spinnaker is now GA, but that's just the beginning of our journey. Now that we actually have the tools for continuous delivery, we want to fully utilize those. So what do our future plans look like? First, for the CD team, we have the daunting task of upgrading Spinnaker. You might have heard us mention a few times, oh, we should upstream some of these changes. Unfortunately, while we were adopting Spinnaker, we've neglected upgrading the open source version of Spinnaker that we run, and we are now several versions behind. What we'd like to do in 2021 is address some of that tech debt and get our version of Spinnaker back in sync with what's currently in open source. So this is going to be a significant investment for the CD team and Spinnaker in 2021. We obviously will continue to invest in Spinnaker scalability and uptime. As we onboard more services onto Spinnaker, we need to make sure that we can continue delivering a great experience. As an infrastructure team, we hold ourselves to a high standard, and we want to at least have 2 nines in terms of reliability for our internal tools, especially a tool that is in the critical path of the deployment flow. We want to make sure that Spinnaker is as stable and always available so that engineers can always deploy their changes to production quickly and efficiently. And that's it. We'd like to thank you for tuning into this presentation. I'm sure you will be hearing more from our journey in the future. Here are our social media links in case you want to reach out. We will also be available in the chat. We hope you've learned something from our journey with Spinnaker, and may your deploys always be smooth and safe. Thank you very much. Bye-bye. Hello. Yeah, I'm here just to answer some of the questions in chat in case folks are interested. I can quickly go over the questions that we have. I think Nima asked, do you use Kayenta as part of your canary analysis, or do you have some internal tooling? So we do use Kayenta. We are planning to make some extensions to Kayenta so that it can work with our tool for feature flags. That's something that we're looking at in 2021, but we are currently just using the native Spinnaker canary analysis. So yeah, that's what we're currently doing. I think Nabil asked, is Anchor available as open source? So it's sort of a similar story to the rest of our extensions. We are like fairly far behind open source right now. So our main focus is catching up with open source in 2021, and then we can look into open sourcing some of this stuff. Specifically Anchor. I know there's an open source solution for declarative pipelines. Anchor was actually built before that existed, but it's something we can definitely look into in the future. How far are we from investigating managed delivery? I think it's going to be on our roadmap for 2022 or like late 2021. Our first goal is to get all deployments onto Spinnaker. We still have a subset of services that are not deploying using Spinnaker, like edge cases, I would say. So those are like gems, NPM packages, EC2 services. So we want to make sure we cover 100% of deploys, and then we'll be looking into managed delivery probably next year. We are pretty excited about that. Great. Unless there are any other questions, I just wanted to thank everyone who's still here for tuning into our presentation, and we hope to talk more with all of you in the future. Take care. Bye-bye.